On this worksheet, you will see that we are pricing 4 separate caplets with strikes of 3% on the top left, 3.01% on the top right, 4% on the bottom left, and 4.01% on the bottom right. In essence, cells K8 to K15 provide prices for 3% digital caplets, while cells K22 to K29 provide prices for 4% digital caplets. Note that we have removed the bottom 2 rows from each spreadsheet to maximize space, as we will not be needing those 2 rows any longer. The trade we will analyze, which has just appeared at the top right of the worksheet, consists of the purchase of a 3% digital caplet starting in 3 years exactly, and the simultaneous sale of a 4% digital caplet for that same period. Cells K13 and K27, highlighted in yellow, show premia of $2,333 and $1,372, bringing the net premium, also in yellow on cell W18, to only $962. Suppose we round the pricing of this four-year caplet combination upward by $38 and offer the entire combination to our customer for $1,000 up front. You should click on the pause button now and draw up a term sheet for this instrument. You should spend no more than 2 minutes on this exercise. The term sheet you produced should look as follows. In essence, the client can convert an upfront $1,000 into $5,000 3.5 years later by taking the view that 6-month Libor in 3 years' time will fall between 3% and 4%. Otherwise, the client would lose the entire $1,000. To understand how we got to this term sheet, note that there are 3 possible outcomes at expiration, as shown in this table. Note also that where the client makes a payment, we have shown that payoff as a negative, which enables us to add across all rows for the investor's total payoff. Outcome 1, Libor is below 3% and all caplets expire out of the money, so the client receives nothing. Outcome 2, Libor resets between 3% and 4%. So the client receives 1 basis point under the first digital caplet, which he owns, but pays nothing under the second digital caplet, which he sold, and so has earned 1 basis point in aggregate. And outcome 3, Libor is above 4%, so the client receives 1 basis point under the first digital caplet which he owns, but also must pay 1 basis point under the second digital caplet which he has sold, and therefore walks away empty-handed once again. We are now in a position to alter the barriers of the range to increase the investor's gain at expiration to any multiple the investor desires, in return for accepting a narrower range of values within which Libor must reset. For example, assume the investor wants to receive 10 times her initial investment if Libor resets within a certain range, and that the lower boundary of that range is kept at 3%. Keeping the payoff at $5,000, i.e. 1 basis point, and the lower boundary at 3%, we solve for the upper boundary that would cause the net premium paid up front by the investor to drop to $500, exactly 1/10 of her payoff at maturity. This is achieved via the goal-seek operator in Excel. We first set the cursor in cell W18, then click on Tools, Goal Seek at the top of the spreadsheet in the File menu. Insert the value 500 in the second line as shown here, and insert C17 in the third line. We are asking Excel to solve for the strike of the second digital caplet that would bring the net upfront premium to exactly $500. When we click OK, Excel has found a solution and informs us that the strike of the second digital, as shown in cell C17, would be 3.47%. Note the significant narrowing of the range given the more ambitious return sought by the investor. In essence, the investor can create a higher and higher multiple gain of her upfront premium by accepting a narrower and narrower range of values within which Libor must reset in order for her to achieve this gain. This is a good place to conclude this module and to ask you to test yourself by answering the 4 quiz questions coming up next.